We're looking at 2b, which is putting numbers into where we previously put words such as strong, moderate, or weak. If I go back a slide to the end of the last session, for instance, you might remember that if you're looking at a diagram, apart from saying whether it's got outliers, you can also say whether it's strong, moderate, or weak, whether it's positive or negative, and whether it's linear or not linear. Now, what we're looking at now is stuff that is linear. We're only going to be looking at linear from now onwards. We do want to know whether it's positive or negative, or in addition to talking about strong, moderate, or weak, we're also going to be giving numbers so that we don't have any confusion about whether... So today then, Pearson. Now, Pearson was a mathematician who is behind all this, English apparently, and he invented something, a way of analysing data by looking at every single point on your thing and working out whether it's a strong, moderate, or weak association. He called it the product moment coefficient, and he gave it the letter R. So if I talk about, or the question in the book asks about finding R, you're finding this number that we're looking for. I'll show you how to do that. So in other words, I'm going to be explaining what a correlation coefficient is and how to calculate it. And as I've said already, numbers are going to be better than words, so I'm going to give some numbers that are associated with those three plots rather than words. Fairly strong, negative, moderate, positive, happy with that, and then nothing much at all on this one here. Now, the numbers that we're going to get are going to range between 1 and -1, as you will see. This is going to generate, and I'll show you how to do it, a value of negative 0.9. This one's going to generate a value of 0.7, so it's smaller than that one, and it's positive rather than negative. This one apparently has got an R value of 0, no pattern at all. So they range between 1 and -1. If you're looking at my hands, -1 over here, very strong negative, 0 in the middle, going up to very strong positive. If you actually had a Pearson value of R is exactly 1, that would be data in a straight line. And the other one on the screen is -1. Now, how do we get them? I've actually told you already, and some of you would have had it on the screen without realizing, you have to have diagnostics on. I've said second function catalog diagnostic on. You can also do what I did before, which was mode. Press the mode button and just go down to stat diagnostic on. You should have some data in there. Has anybody not got any data in L1 and L2 already? So stat edit, have a look and see if you've got any data in there already. And then stat calc should give you a display that looks like this. If you use, I don't know what data was in the calculator when I made this slide a couple of years ago, but it's got the information here. You're going to need all of this eventually. First three lines are the gradient of the line that goes through the data. So y equals ax plus b. A is the gradient and b is the y-intercept, if you remember that from past years. So it's got a gradient of 0.86 and an intercept of -84. We don't need that just yet. What you do need is this last one here, r, 0.85. Now, I'll help you turn 0.85 back into words in just a moment. But can you all make sure you've got some data in your calculator and you can get a screen that looks like that? Because I don't want to go any further until it... Right, let's go back to this then, please, everywhere. There's a red information at the bottom, which is going to be important for answering the questions in the exercise and in tests. This only works when you've got linear data, numeric, obviously, and no outliers. Now, if you're asked to do an analysis of some numbers, and then if you plot it, it doesn't look linear, then you're wasting your time. We don't go any further. If it's got an outlier, you can continue, but you must remove the outlier from the data. Now, that's just getting something into the future, but you'll need to remember that for later. Look at the number you've got for R and decide where it fits on this table here, because this is turning the number back into words. So if you've got a value of 0.9, that is strong positive. If you've got a value of -0.2, Negative 0.2, there's no association at all. So this is turning the number, this is interpreting the number in words more precise. Instead of guessing whether a data is linear, is weak or strong, you get R value and you read off this table. And we've got strong, moderate, or weak, and these are all positive. And so 1 would be perfect, but you never get perfect. Negative 1 would also be perfect, but you never get perfect. So it's perfect positive, perfect negative, because the data is in a straight line. Gentleman says, how can you not get perfect? We had here, these are perfect, but you're not. So there's two things that come up in the exercise. Two things you've got to remember when you do the exercise, which is not very long, but one of them is make sure the data is linear, it's numeric, and there's no outliers. And secondly, this is how you interpret your R value. So your first question, that's what I just said, linear, no outliers, and numeric. Don't try and use the R value if the data has got an outlier in it. Take the outlier away. It's all in the textbook, as you can see. So here's your first questions. So question 1, what 3 assumptions do you make when using the value of the correlation? What 3 assumptions do you make when using the value of the correlation coefficient R as a measure of the strength of an association? Those are the assumptions. The correlation coefficient is produced from numbers. It's linear and no outliers. So that's the answer to question 1. You remember what it said?